In question number 25, they want us to find the domain and the range from the graph. Remember, on the domain, you're looking on the x-axis. You want to ask the question, how far left to how far right does the graph go? Well, if we notice that the fact that this thing has arrows, it's going to continue to move up as we move to the left. So it'll go all the way to the left. And also, this graph's going to extend all the way to the right. So it's going to cover the entire x-axis, which is going to be from negative infinity to positive infinity. So remember, when you're looking at the domain, you're looking on the x-axis. How far left to how far right does the graph extend? For the range, now we're going to look at the y values. How low to how high does the graph go? Well, the lowest point on the graph is this value right here on the y-axis, which is 1. And then we see that, in either direction, it's going to shoot all the way up towards positive infinity. So the lowest y value is 1. It goes all the way up towards positive infinity. So the range would be from 1 to infinity. If we take a look at number 26, they ask the same questions. So we want to find the domain and the range from the graph. If we look at the domain first, notice that it has arrows in this direction and this direction. So this graph goes all the way to the left. It goes all the way to the right on the x-axis. So the domain would be all real numbers, or negative infinity to positive infinity. For the range, this graph goes as low as y equals to 0. And because of the presence of this arrow here, it will continue to go up and up and up as we go to the right and tend towards positive infinity. So the range would be from 0 to positive infinity. In question 27, they want us to get the domain from the equation of the function. For question 27, this function f of x is a rational function. The domain is a collection of all x values except where the denominator would be 0. So to find the domain, you take the denominator, you set it equal to 0 and solve. You add 6 to both sides, and we would get that x equals to 6. We've called that in the past our restricted value. So it would be all real numbers except 6. You can write it as x not equal to 6. In interval notation, that would look like everything to the left of 6. So it's from negative infinity up to, but not including 6. So it gets a parenthesis, union, then everything directly to the right of 6, which would be from 6, again not included, so parenthesis, to positive infinity. For question 28, we have f of x equals 8x minus 3. This is simply a polynomial. No matter what value of x you pick, you can always take any real number. You can multiply it by 8, and that'll give you an answer. And then from that answer, you can always subtract 3. So for this function, you can plug any real value of x in, which means that the domain would be all real numbers. Okay, so it's all reals, which in interval notation we would write as from negative infinity to positive infinity. And this is true of polynomials in general. If you have a polynomial function, its domain is always going to be all real numbers. Let's take a look at another graphing question. In number 29, they give us the graph of a function. This is g of x. The first thing they want us to do is find the value of g of negative 4. Well, when x is negative 4 is right here. We trace it up. The graph is located here, which has the y value of 2. So we would say g of negative 4 is equal to 2. The second question says, for what value of x is g of x equal to 1? Well, if we look at all of the places that have a y height of 1, that would be right here. That horizontal line intersects the graph of g precisely when x is negative 2. So when x is negative 2, g of negative 2 would be equal to 1. So our value there would be x equals negative 2.